right, here we go. Question 29 from our Precalculus, homework number 3. In MyLab Math, they want us to solve the exponential equation. They do want the exact value, so no decimal approximations. And I'm going to attack this problem as if I really don't know how to do it, and I'm going to demonstrate kind of how you can hunt for things to do to try to work your way to the solution. So what I notice is the first term is 16 raised to the power of x, and I do happen to notice that the other term has a base of 4. So one of the things we've covered in this homework assignment is called the method of common bases. So maybe what I need to start thinking about is getting a common base. So I'm going to rewrite the 16 as 4 squared, and that is going to be raised to the power of x. Notice that this term now has a base of 4. And for the time being, I'm going to leave 4 to the x plus 1 the way it is, hoping I can work with that. Since the 1 doesn't have an exponential, I'm going to go ahead and bring that over to the other side just because I'm trying to figure this out, okay? That just seems like something that feels right to do. So, simplifying the first term, we know that an exponent raised to another exponent, that's going to indicate multiplication, which is going to give me 4 to the 2x plus 4 to the x plus 1 equals 1. So where am I at? I do have a common base, but we cannot add things that have the same base unless they have the same power. So I'm not quite there yet. Okay, so after some thought, I've actually thought that there may be a way to simplify this exponent and make it not addition anymore. Just trying to troubleshoot here. So one of the properties of exponents says if I have x to the a times x to the b, I can simplify that as x to the a plus b. What I want to try to do is I want to try to go backwards here. So I have x plus 1. I want to see if I can go backwards so that I have 4 to the x times 4 to the 1. Let's see how that would look. Okay, so breaking this guy down, that would be 4 to the x times 4 to the 1, which is just 4, equals 1. And you see, if I try to go backwards, I have the same base, so I would add their powers, giving me 4 to the x plus 1. So I feel good about this step. Not that I'm sure it's the right step, I just know that this is a valid step. I also know that this term, the way it was written as 4 squared to the x, I could probably rewrite that with those exponents flipped and say 4 to the x to the 2. And so now if you notice, I'm getting closer to having something that's identical. I now have 4 to the x in both of these terms. Okay, so now that I've given this a little bit of thought, what I know is in a problem like this, if I have an identical factor, here I've got the 4 to the x appearing twice, there is a thing called a u substitution. So we're going to say let u equal 4 to the x. And what that will allow me to do is replace every 4 to the x with simply a letter u. And doing the u substitution can make a complex looking problem into a much simpler looking problem. So here we go, doing the u substitution, 4 to the x, that's going to be u squared plus, again, 4 to the x, that's going to be u times 4 equals 1. And so if I simply swap these factors, I can see that I have a basic quadratic equation. So u squared plus 4u, and now I'm not sure about this 1. Maybe I shouldn't have brought it over. You know what? I'm going to run with it. Let's say that I leave it over there. Notice at this point I do have a basic quadratic equation where completing the square is a valid technique to solve this. So we're going to demonstrate completing the square to solve for u. Once I have the solutions for u, I can go back where I did my u substitution, replace u, and then I can solve for the actual variable x. All right, so doing the completing the square process, we're going to take half of b, half of 4 is 2, and then square that gets me my new constant. Whatever you add to one side, you have to add to the other. And so that's going to bring me to the point that I have u squared plus 4u plus 4, which is a perfect square trinomial, which means that is going to factor nicely. On the other side, 4 plus 1 is 5. Now to factor the trinomial, the signs are both going to be positive. U and u, numbers that multiply to make 4 and add to make 4, 2, and 2. Notice when I said it's a perfect square trinomial, that indicates that the factors are identical. And anything times itself can be written as that thing squared. I'm getting close, okay? I need to square root both sides to get rid of the squared. Going to give me u plus 2 equals, don't forget your plus or minus, square root of 5. 5 doesn't square root nicely. We're going to leave that in radical form. And we're going to bring the plus 2 over to isolate the u, giving us negative 2 plus square root of 5 and negative 2 minus square root of 5. So recall we said let u equal 4 to the x. We are now going to substitute for u and put it back in terms of 4 to the x equals negative 2 plus square root of 5. And we're also going to have 4 to the x equals negative 2 minus square root of 5. Now this particular equation is going to have no solution because this value is going to be negative. And you cannot raise a positive number to any power and have it come out negative. So that's going to result in a dead end over here. On the other side, 4 to the x equals negative 2 plus square root of 5. Solving this exponential equation by converting to logarithms will give me log base 4 of negative 2 plus square root of 5 equals x. Notice we're doing the poem, bring the base down, switch the other two around, and that does a great job of isolating the variable. And if we want, we can actually use the class whiz to see if this is going to be a valid solution or give us an error message. Using the log base button, log base 4 of negative 2 plus square root of 5 does give us an answer. So that is going to be our solution. All right, checking our solution in MyLab Math, spelling out the log. Please don't forget your base of 4. And then we're going to need parentheses so that it indicates we're taking the log of all of the stuff, negative 2 plus square root of 5. And we do need to close that parenthesis. Oh yeah, make sure you move out from under the square root before you close your parenthesis. And that's going to do it for that particular problem. So if you have any questions or comments, please feel free to leave those in the comment section below, or you can text me. And thanks for watching.